Here we have an interesting question. It is given that the carbon-carbon single bond distance is 1.54 angstrom. We need to find out the distance between the two terminal carbon atoms in propane. So for propane we have the structure is like this with hydrogen here. This is not the actual geometry of the substance but just a structural diagram. We need to find out the distance between these two terminal carbon atoms when it is given that the 4 bonds of any carbon atom are pointed towards the corner of a regular tetrahedron. Therefore, consider this carbon atom. Let us name it C1. This is C2. This is C3. Now for C1, we will be having these two at the two corners of the tetrahedron with C1 at the center of the tetrahedron. This is a single bond. Therefore, this we know as 1.54 angstrom. This is again 1.54 angstrom. What we need to find out is the distance between C2 and C3. We know that in a regular tetrahedron, this angle is equal to 109 degrees 28 minutes. Now, to find out this distance, we drop a perpendicular from here. We know that alpha is equal to 109 degrees 28 minutes, that is this full angle. This will be alpha by 2, this will be alpha by 2. Therefore, we can write this side to be equal to 1.59 into sine alpha by 2. That is 1.54 into sine alpha by 2. This is the length of this portion. Now, the length of this portion will be equal to the length of this portion. Therefore, this becomes 2 times. Therefore, the distance between the two terminal carbon atoms comes out to be equal to 2 into 1.54 into sine of alpha by 2. This is equal to 2 into 1.54. This is angstrom, mind you, into sine of 109 degrees 28 minutes upon 2, that is equal to 54 degrees 44 minutes. Sine of 54 degrees 44 minutes. On finding out the value and substituting over here, we get into 0.82 is equal to 2.52 angstrom. So final answer for the distance between two terminal carbon atoms comes out to be equal to 2.52 angstrom in propane.